Welcome to the lesson on using studies wisely. Researchers often want to draw conclusions that go beyond the data they produce. This is called inference. An example we'll look at is vitamin C and canker sores. A small-town dentist wants to know if a daily dose of 500 milligrams of vitamin C will result in fewer canker sores in the mouth than taking no vitamin C. The dentist is considering the following designs. Design 1. Get all dental patients in town with appointments in the next 2 weeks to take part in the study. Give each patient a survey with 2 questions. 1. Do you take at least 500 milligrams of vitamin C each day? 2. Do you frequently have canker sores? Based on the patient's answers to question 1, divide them into 2 groups, those who take at least 500 milligrams of vitamin C and those who don't. There is a couple things we need to take into consideration. Whichever design the dentist chooses, she will compare the proportion of patients in each study group who complain of canker sores. Also, she finds a statistically significant difference with those taking vitamin C having less occurrence of canker sores. The problem that we need to analyze is what can the dentist conclude from each study? Okay, so we go back to the design 1, and the dentist chose patients that already take vitamin C and have an appointment within the next 2 weeks. So what does that mean? That means the patients were not randomly selected. Since the patients were not randomly selected, the dentist cannot infer that the results holds for a larger population of dental patients. The reason the dentist cannot infer that the result holds for a larger population of dental patients is because not every single dental patient had the opportunity to be sampled in this study or chosen as an individual for the study. So what kind of study was this? Was it an observational study or an experiment? It is an observational study, not an experiment, because no treatments were deliberately imposed on the patients. The individuals selected in this study or design were already taking vitamin C or not taking vitamin C, and were selected for as far as they had a dentist appointment in the following 2 weeks. That is why it's an observational study. It's because they were already either taking the treatment or not taking the treatment before the study occurred. Now, can we make an inference in terms of cause and effect? And that is no, because there was no random assignment to the 2 groups. Alright, for design 2. The dentist will get all dental patients in town with appointments in the next 2 weeks to take part in a study. She will randomly assign half of them to take 500 milligrams of vitamin C each day and the other half to abstain from taking vitamin C for 3 months. We need to still look at what the dentist can conclude from this particular type of study. As in design 1, the dentist can't make any inference about this result holding for a larger population of dental patients. However, the treatments were randomly assigned to the subjects. Assuming proper control in the experiment, she can conclude that taking vitamin C reduced the chance of getting canker sores in her subjects. So let's discuss why the dentist can't make any inference about this result holding for a larger population of dental patients. The reason she can't make this inference is because, again, all the dental patients did not have the same opportunity to be chosen as an individual for this study. They did not have the same probability of being randomly assigned to the study. The question is, can she make any conclusions about the subjects that were chosen? And the answer to that is yes. Why? Because assuming proper control in the experiment, she can conclude taking vitamin C reduced the chance of getting canker sores in her subjects because treatments were randomly assigned to the subjects. Now let's take a look at design 3. The dentist will select a random sample of dental patients in town and get them to take part in this study. She divides the patients into 2 groups as in design 1. And going back to design 1, the 2 groups were patients that already took 500 milligrams of vitamin C and patients who did not take 500 milligrams of vitamin C. The first question we have to ask is, Can this dentist make an inference or generalization as to the results towards the whole population? And the answer to that is yes. Since the patients were randomly selected from the population of dental patients in the town, the dentist can generalize the results of this study to the population. Now, because like in Design 1, this is an observational study. So what does that mean? You cannot make an inference about cause and effect when it's an observational study, due to the fact that no treatments were imposed on the individuals. Well, what can she say about this particular study? She can't say whether the vitamin C causes the reduction or some other confounding variable, but what conclusion she can draw is that those people that in the general population of the town that take vitamin C have fewer canker sores than those that do not take vitamin C. Now for the last design, Design 4. The dentist will select a random sample of dental patients in town and get them to take part in a study. She will randomly assign half of them to take 500 milligrams of vitamin C each day and the other half to abstain from taking vitamin C for 3 months. As in Design 3, the random sampling allows the dentist to generalize the results of this study to the population of dental patients in the town. As in Design 2, the random assignment would allow her to conclude, assuming proper control in the experiment, that taking vitamin C reduced the chance of getting canker sores. Now, as in Design 3, she cannot extend this result to the general population of the town, only to those that were dental patients. The whole town would have to have been candidates to be chosen for this particular study in order for the results to be extended to the whole town. This will conclude this example, and thank you for joining me for this lesson.